Howdy! Today we're going to learn how to do limiting reactant problems with stoichiometry. This is actually the last problem in your note-taking guide, so if you weren't here today, we are in the note-taking guide on the very last page. I know it's going to be a limiting reactant problem if I'm given two different values for my given. So I was told that there's 15.5 grams of aluminum reacting with 46.7 grams of chlorine. So I've got two given values. I'm going to have to work a separate problem each time I have a given. So I'm going to have two separate problems here. Then aluminum chloride is formed. Which reactant's limiting? Which reactant is in excess, meaning there's leftovers? And what is the mass of aluminum chloride produced? So I have two problems. We're going to work two problems, both of them going to mass of aluminum chloride. Since I see that I'm going to be moving from one element to a different compound, this is stoichiometry, and I know that I'm going to need a balanced chemical equation. So that's my first step, get a balanced chemical equation. Aluminum is reacting with diatomic chlorine. So I have aluminum plus chlorine, which is part of Brinkelhoff, so it gets the 2, and it told me that, to form aluminum chloride. Aluminum chloride is formed. To balance this, I see that chlorine has a 2, chlorine has a 3 here. I can make them both equal 6. I'm multiplying this one by 2 to get 6 chlorines, and this one by 3 to get 6 chlorines. That causes me to have 2 aluminums here, so I need to put a 2 here. Now I have my balanced chemical equation, so I can start my stoichiometric calculations. So my first part of the problem says I have 15.5 grams of aluminum. So let's just work on that first. I have 15.5 grams of aluminum. Put it over 1. Okay? My unit on top, grams of aluminum, comes down to the bottom. And from grams, there's really only one place I can go. From mass to moles, using the molar mass on the periodic table. So that's what I'm going to do first, go from grams to moles. Of aluminum still, can't change. And this is the molar mass on the periodic table. When we round it to the 10th place, it's 27.0 for aluminum. It's 27.0 grams per 1 mole. It will always be a 1 next to moles when we're doing molar mass. So currently, grams of aluminum have canceled because they're across from each other. And I'm in moles of aluminum, but my goal is mass of aluminum chloride. So I still have to keep going. Moles of aluminum comes down to the bottom. Once I'm in moles, I can switch from moles to moles of what I'm looking for using the coefficients from the balanced equation, which I have up here. So I can switch to moles, and here's where I can finally change from aluminum to what I'm looking for, which is aluminum chloride. Okay, using the coefficients from the balanced equation. So AlCl3 has a 2. Aluminum also has a 2. So I'm not done yet because it specifically was asking for mass of aluminum chloride. So I need to get to grams. And from moles, I can move to mass of aluminum chloride. Okay, again using molar mass, which I find on the periodic table. It's a compound, so I'm going to have to calculate that. Moles of aluminum chloride comes down to the bottom. And I can switch to grams. It'll always be 1. I have to calculate the molar mass of aluminum chloride. So it's 1 aluminum plus 3 times chlorine. I get 133.3. Okay, moles of aluminum has canceled. Moles of aluminum chloride has canceled. I'm in grams of aluminum chloride. Okay? Also, the 2's cancel because times 2 divided by 2 is 1. So it's 15.5 times 133.3, and then divide that by 27. And I get 76.5 grams of aluminum chloride. Now this may or may not be the answer. Okay, since I had 2 givens, I have to work 2 different problems. Okay, it's kind of like if you have a recipe and you have 30 eggs, you can make a ton of cupcakes with 30 eggs, but if you don't have enough sugar to make that ton of cupcakes, then that's not your answer. So that's what we're going to try and see here. Now I'm going to deal with my second one, my second given, 46.7 grams of chlorine. Same exact process, but I'm starting with chlorine. I need to move to the exact same thing this one moved to so that I can compare my two answers, okay, and see which one actually limits me. Same exact process. Okay. So my unit on top comes down to the bottom, grams of chlorine. From grams, we know I can move to moles of chlorine using the molar mass on the periodic table. However, there are two chlorines here, so be careful and remember to double your molar mass. Moles of chlorine comes down. And I can switch to moles of aluminum chloride. We're going to the same thing. We're doing two problems, both of them moving to mass of aluminum chloride. First, though, I have to go to moles using the coefficients from the balanced equation. So aluminum chloride again has a 2. Chlorine has a 3. Okay. So my unit on top comes down. I'm trying to get to mass of aluminum chloride, which I can do by using the molar mass. 1 always goes by moles when we're dealing with molar mass, both times. Okay, and the molar mass of aluminum chloride is 133.3. Everything cancels except for grams of aluminum chloride, which is what I want. So I'm going to do 46.7 times 2 times 133.3. Then I'm also going to do 71 times 3 and then divide my two answers, which is going to give me 58.5 grams of aluminum chloride. Okay, I got two answers. My answer is going to be the smaller of the two answers. So this is how much is actually going to be produced. And this number is essentially useless. Okay, that's always how it's going to be. You're going to have one that's valid, a smaller answer, and one that's useless. This is how much is actually produced. So this is the answer to C. What's the mass of aluminum chloride produced? So C is this. A says which reactant is limiting. So A, limiting. And B says which one is in excess, meaning has leftovers. So the limiting is the one that held me back at the smaller answer. So chlorine held me back. That means I run out of chlorine and I only am able to produce 58.5 grams of aluminum chloride before I run out of chlorine. Aluminum said I could have gone all the way to 76.5 grams, but it can't because I stopped here. Chlorine ran out. Okay, and the reaction stops at 58.5. So chlorine limited me at 58.5. Excess is the bigger answer. So aluminum was able to get me more. Since it doesn't get all the way to 76, it stops at 58, there's going to be leftover aluminum. Okay, so there's A, which is limiting, B, which is excess aluminum, C, what's the mass produced, D says what's the percent yield if 55.0 grams is actually produced in the laboratory. So if we did a lab and only produced 55.0, but we were supposed to produce 58.5, basically how good did they do in the lab? What was the percent yield? Okay, so my percent yield equation, as you see higher up on your notes, is actual yield divided by theoretical yield times 100. They have to tell you the actual yield every single time, or else you're going to have to do a lab to figure it out. So 55.0 grams was actually produced, divided by the theoretical yield, which we calculate. Theoretically, I should have been able to make 58.5, but I actually only made 55. So actual divided by theoretical times 100 gives me my percent yield. How much did what percentage was I actually able to recover in a lab setting? So 94%. Okay. I added a little bonus question as well, which said how much excess is actually left over. So I know I have excess aluminum. I had a little bit left over. How much aluminum was truly wasted? The way we work this is I know that the reaction stopped at 58.5 grams of aluminum chloride. So if the reaction stopped here, I need to figure out how much aluminum was made how much aluminum was used just to get to this value. So start with this value, my bonus question. Start with that value. Over 1. And we're going to go back to my excess, which was aluminum, and see how much aluminum was used just to make this. So grams aluminum chloride comes down to the bottom. I can switch to moles of aluminum chloride using the molar mass. Okay, grams aluminum chloride cancel. I'm in moles aluminum chloride. Moles aluminum chloride comes down to the bottom. And once I'm in moles, I can switch to moles of what I want. I want my excess aluminum. Okay. Mole ratio, I'm going to use the balanced equation. So aluminum has a 2 in front of it, and aluminum chloride also has a 2, so those are going to cancel. Moles aluminum comes down to the bottom. And now I'm able to go back to grams of aluminum. I want grams of aluminum because I started in grams of aluminum. So I'm going to compare how much was used to how much I started with, and that will show me how much is left over. So the molar mass of aluminum is 27.0 grams per 1 mole, always 1 for molar mass. Everything canceled except for grams aluminum. So if I calculate this, these also cancel. 58.5 times 27, and then divide that by 133.3. And I'm going to get 11.8 grams of aluminum. This is not my answer though. This is how much aluminum was used to make 58.5 grams of aluminum chloride. Okay? And that's not what the problem wants. The problem wants how much is left over. Well, I used this much, and I started with 15.5 grams. So 15.5 grams aluminum started with. And then 11.8 grams used. To only make 58.5. If I subtract those, I get 3.7 grams. And that's how much is left over after only making 58.5 grams of aluminum chloride, and that's when the reaction stops. So this is my answer. 3.7 grams was left over. So if we do this calculation first, we can see that I don't need to put in 55 grams of aluminum, really only needed to put in 11.8, and I can save some waste. Okay? So this is pretty much every single step that you could possibly be asked for in a limiting reactant problem. Not only what's the limiting and what's the excess, how much is made, okay, which is your smaller answer, what's the percent yield, and how much was left over. Usually a problem doesn't ask you every single one of these steps, but I wanted to combine them all in one problem so you can see them all at once. All right, I hope this was moderately helpful. Bring your questions to class if you have any. Thank you.